Now, associated colloids, their formations, how they are formed and how they are different. Associated colloids revert back to the individual ions on concentration below critical micelle concentration. Surface active agents like soaps, synthetic detergents belong to this class. Critical micelle concentration is 10 to minus 4 to 10 to minus 3 moles per liter. Let's say micelle formation. As we discussed, it having two ends. One is a polar, one is a non-polar. So micelles are dipolar molecular aggregate. Their formation happens only below, above certain critical concentration. At critical micelle concentration, anions are pulled into the bulk of a solution and aggregate to form spherical. This is a sphere-like shape. We have just saw you. These are anionic ends. And carboxyl part remain outward pointing on the surface of the sphere. Let me see here. Sodium lauryl sulfate. This is nothing but 13 carbonate long chain with sulfate group and sodium ion. Here we see hydrocarbon chains are pointing towards each other and anionic part pointing toward the bulk of the solution. Cleansing actions of the soap. Since soap molecules form micelles around the oil droplets in such a way that hydrophobic part ions anchored in the oil and hydrophilic part anchored into the water. We see this is oil grease on our stain, making a stain on our cloth. On applying the soap or detergent, what happens? These are hydrocarbon chains of soap or detergent. They totally dip into the oil or grease. Now, that's all. These are anchored into the oil droplets. And these are anionic parts pointing outwards. They interact with the water. Now, earlier, the oil was not able to interact with water. This is hydrophobic. But because of these detergents, which having a bipolar ends, one hydrophobic part interact with oil and other hydrophilic part interact with water, able to remove the grease or stain from cloth. We have discussed about the colloidal solutions so far, their classification, but how to prepare them. Very first method is chemical method. We can prepare through chemical methods by double decomposition, oxidation, reduction or hydrolysis. These molecular methods results in aggregation of molecules to give us a colloidal solutions. Very first example is we having a arsenious oxide will reacted with hydrogen sulfide, which undergo a double decomposition, as you know, because here oxide is converted into sulfide. There is no change in this oxidation state, and here hydrogen is this exchange of basically sulfur and oxygen between these two entities. That's why we call it a double decomposition, because both decomposes. Or we also can it as a replacement reaction. Next is oxidation. We oxidize sulfur dioxide using hydrogen sulfide. We getting a sulfur sol got reduced. Next is our gold trichloride. This is nothing but formaldehyde. When we react with it, it got reduced. In this part, ferric chloride again, we hydrolyze it to get a ferric hydroxides over sol. So these are the few methods to prepare our different elemental salts like gold, sulfur, arsenious sulfide and ferric hydroxide salts. Here you might be surprised to see it as oxidation because this sulfide got oxidized here. Now, Briggs arc method to prepare colloidal salts. Colloidal salts of metals such as gold, silver, platinum, etc. are prepared through striking an electric arc between the electrodes in a suitable dispersion medium, which we cool it using ice bath or any other suitable medium. Then we pass a current. Intense heat is produced that instantly vaporizes the metal, and those metal particles got suspended in dispersion medium to give us a metallic colloidal solution. That's what happened. We're getting these metal colloidal solutions. Next method is peptization. Peptization may be defined as the process of converting a precipitate into a colloidal solution by shaking it in a dispersion medium in the presence of a small amount of electrolyte. So converting a precipitate into a colloidal solution with shaking a suitable electrolyte in small quantities is known as peptization. The electrolyte used is called peptizing agent. Let's take an example. We are having a ferric hydroxide precipitate, these particles. We'll add ferric chloride solution to it, which acts as a peptizing agent. What happens? The precipitate selectively absorb, this ferric hydroxide precipitate selectively absorb ferric ions from it. So these are got positively charged surfaces. Once they do so, they are all similarly charged. So particles start repelling each other and they got dispersed in dispersion medium, and the size of particle will be colloidal range. This development also basically our peptizing agent gets selectively absorbed on the precipitate surfaces, and through Coulombic repulsions they make colloidal particles, and this is how they are stabilized in dispersion medium.